this week, what I'm going to do is I'm going to go straight into the video first, and then I'll come back and start the slide presentation.
Does God exist? Or is the material universe all that is, or ever was, or ever will be? One approach to answering this question is the cosmological argument. It goes like this: whatever begins to exist has a cause. The universe began to exist, therefore, the universe has a cause. Is the first premise true? Let's consider. Believing that something can pop into existence without a cause is more of a stretch than believing in magic. At least with magic, you've got a hat and a magician. And if something can come into being from nothing, then why don't we see this happening all the time? No, everyday experience and scientific evidence confirm our first premise. If something begins to exist, it must have a cause. But what about our second premise? Did the universe begin, or has it always existed? Atheists have typically said that the universe has been here forever. The universe is just there, and that's all. First, let's consider the second law of thermodynamics. It tells us the universe is slowly running out of usable energy, and that's the point. If the universe had been here forever, it would have run out of usable energy by now. The second law points us to a universe that has a definite beginning. This is further confirmed by a series of remarkable scientific discoveries. In 1915, Albert Einstein presented his general theory of relativity. This allowed us, for the first time, to talk meaningfully about the past history of the universe. Next, Alexander Friedmann and George Lemaitre, each working with Einstein's equations, predicted that the universe is expanding. Then in 1929, Edwin Hubble measured the red shift in light from distant galaxies. This empirical evidence confirmed not only that the universe is expanding, but that it sprang into being from a single point in the finite past. It was a monumental discovery, almost beyond comprehension. However, not everyone is fond of a finite universe, so it wasn't long before alternative models popped into existence. But one by one, these models failed to stand the test of time. More recently, three leading cosmologists, Arvind Borde, Alan Guth, and Alexander Vilenkin, proved that any universe which has on average been expanding throughout its history cannot be eternal in the past, but must have an absolute beginning. This even applies to the multiverse, if there is such a thing. This means that scientists can no longer hide behind a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. Any adequate model must have a beginning, just like the standard model. It's quite plausible then that both premises of the argument are true. This means that the conclusion is also true. The universe has a cause. And since the universe can't cause itself, its cause must be beyond the space-time universe. It must be spaceless, timeless, immaterial, uncaused, and unimaginably powerful, much like God. The cosmological argument shows that, in fact, it is quite reasonable to believe that God does exist.
So let's get started. All right, so this week we're doing a second cosmological argument. So we did another cosmological argument last week, which was the argument from contingency. So the argument we're talking about this week is called the Kalam cosmological argument. And it's very simple and easy to remember. The premises are, at least. The first premise is whatever begins to exist has a cause. So note It doesn't say whatever exists has a cause. It says whatever begins to exist has a cause. That is misunderstood by so many people. In fact, there's a lot of atheists that think that the argument actually says whatever exists has a cause. And that is not the argument. It's whatever begins to exist has a cause. The second premise is the universe began to exist. And if those two are true, then the universe has a cause. So it's very, very simple argument to remember. Now, the tough part is going to be proving the second premise. Actually, it's not tough. I think it's easy to prove, but that's where the heavy lifting comes in the argument. So we're going to end up spending most of the time talking about that second premise. So, but a quick defense of premise one, which is whatever begins to exist has a cause. So something cannot come from nothing. We talked about that last week. To claim that something can come into being from nothing is worse than magic. You know, at least with magic, you have something there that you can appear to bring something out of. But to say something can come from nothing, or that something can exist and be caused by nothing else, is absurd. If something can come into being from nothing, then it becomes inexplicable why just anything or everything doesn't come into being from nothing. In the video, it had, you know, rabbits and people and cars just popping into existence. And that's what the universe would be like if something could come from nothing. We would just have things popping into existence constantly all around us. And yet none of us has ever seen anything like that. So common experience and scientific evidence confirm the truth of premise one. Premise one is constantly verified and never falsified. Most people that I've talked to do not deny this premise. So it's usually premise two is where it gets interesting. So in the book, Bill Craig basically gives 4 arguments in support of premise 2. He gives 2 arguments from philosophy, and he gives 2 arguments from science. So I'm going to go through all 4. Now, keep in mind, when he gives 4 arguments, he's just piling on. If even one of these arguments is true, the premise is true. So, but he's going to give 4 arguments for why we should believe the universe began to exist. And the first 2 arguments from philosophy have to do with the concept of infinity. And I will go ahead and tell you that this concept of infinity and trying to understand how it fits into the argument is difficult to understand. The group that I taught Sunday morning, this is where we spent a lot of time kind of discussing what infinity is. However, if you don't understand these 2 arguments from philosophy, it doesn't matter, because we then have the 2 arguments from science coming up next, which are a lot easier to understand, at least in my opinion. But I don't want to skip over the 2 philosophical arguments, because I think they're very powerful, and if you understand them, so the first philosophical argument is that an actually infinite number of things cannot exist. If the universe never began to exist, then there have been an infinite number of past events prior to today, but an infinite number of things cannot exist. So think about, if we just count backwards, you know, by seconds or hours or days, whatever units you want to use, let's just use seconds. If the universe never began to exist, then there have been an infinite number of seconds prior to today, or if days is easier, there's been an infinite number of days prior to today. But what we're saying is that an infinite number of things cannot exist. So let's talk about that, because when you first hear that, it doesn't sound right. At least the first time I heard it, I'm like, well, what do you mean an infinite number of things can't exist? I mean, people talk about infinity all the time as if it's real. So how can you say that? So the concept of infinity cannot be applied to reality. It is just a mathematical construct that mathematicians have invented the concept in order to be able to talk about properties of certain sets. And I want to show you this very helpful web page called mathisfun.com. And I'm going to go to this web page. This is not a Christian web page. This is not a Christian apologetics web page. This is just a guy that teaches math, okay? But when it was literally the first thing that came up, I think, in my Google search when I typed in what is infinity, or what is infinity in mathematics or something. This website came right to the top, and it is perfect because it totally proves Bill Craig's point. I mean, you can't do a better job. So let me just switch over to that website. All right, so here it is. Math is fun. What is infinity? So I'm just going to go through the first few sections of this web page. So infinity, it's not big, it's not huge, it's not tremendously large, it's not extremely humongously enormous, it's endless. It has no end. So he goes on to say, infinity has no end. It is the idea of something that has no end. In our world, we don't have anything like it. Very important sentence. So we imagine traveling on, trying hard to get there, but that is not actually infinity. So don't think like that. It just hurts your brain. Just think endless or boundless. If there is no reason something should stop, then it is infinite. Infinity does not grow. Infinity is not getting larger. It is already formed. Sometimes people say it goes on, which sounds like it is growing somehow, but infinity does not do anything. It just is. And then notice the next section. It says, infinity is not a real number. Like, that's like the money line from this webpage. Like, if you don't understand anything else on this webpage, just infinity is not a real number. It is an idea of something without an end. Infinity cannot be measured. Even these faraway galaxies can't compete with infinity. So there's no such thing as an infinite number of real objects or past events or anything. That's the point I'm trying to get across. So let me go back. So in the book, he used this illustration of Hilbert's Hotel, where he has this hotel and it has an infinite number of guests and all the rooms are full in the hotel. So there's no vacancy in the hotel. So someone shows up at the hotel and says, I want a room. And the hotel manager is able to just shift everyone and add the person to the hotel. Well, that's absurd because the hotel was full. There's no vacancies. So how did a new person come and check into the hotel if all the rooms were full? And in fact, you could add an infinite number of people to the hotel as new guests, and the manager can always make room for them. Well, why is that? Look at these special properties of infinity, and this will maybe help out. So look at the first one here. Infinity plus infinity equals infinity. So think about if you have a big number, well, I'll take a number 1,000. If I take 1,000 and I add 1,000, right, I have 2,000. But in the case of infinity, if you thought of infinity as a number, it would be 1,000 plus 1,000 equals 1,000. So infinity is not a number. And that's why the hotel manager can always add an infinite number of guests, right? Because as long as there's an infinite number of guests in the hotel, he can add an infinite number. If you go down here, you see any number plus infinity equals infinity. So it doesn't matter what you add to infinity, it's still infinity. If you multiply infinity by itself, it's still infinity. So hopefully what I'm trying to get across here is the concept of infinity cannot be applied to reality. Like, you cannot have an infinite number of past events because there's no such thing as an infinite number of anything that's real, that exists in the real world, that is a concrete object. All right, so that's all the time I'm going to spend on that. Hopefully you got it. If you didn't, don't worry about it, because we're going to get to the scientific arguments in a minute. All right, so the next philosophical argument, and this is similar to the first one, but slightly different. It says you can't pass through an infinite number of elements one at a time. So the series of past events has been formed by adding one event after another, right? One day after another. So the series of past events is like a sequence of dominoes falling one after another until the last domino, which would be today, is reached. But no series that is formed by adding one member after another can be actually infinite. You cannot count to infinity. And that agrees with the webpage we just read. Like, that guy said the same thing. You can't count to infinity because you never get there. So if you can't count to infinity, then how could you count down from infinity? This would be like trying to count down all the negative numbers ending at 0. So -3, -2, -1, 0, I've arrived. But this seems crazy. Before you could count 0, you'd have to count -1. But before you could count -1, you'd have to count -2, and so on back to infinity. So before any number can be counted, an infinity of numbers will have to have been counted first. You just get driven back and back into the past so that no number could ever be counted. So hopefully you see that you can never start. Because it's like, well, I'm going to count -10 to the 130th power. Well, there's still a number bigger than that. So you still can't start there, right? So you just keep getting pushed further and further back into the past. So the first domino can never even be knocked over if we literally had an infinite number of past events. So, but we've arrived today, right? That's what this domino is right here. This is today. And so somehow for this domino to be knocked down, we had to start back here a finite time ago with some finite number of dominoes. If the dominoes were infinite, we could never have arrived at today. So the final domino, or today, could never fall if an infinite number of dominoes had to fall first. So today could never be reached. But obviously, here we are. So this shows that the series of past events must be finite and have a beginning. All right, so before I move on, are there any questions about that? Any way I can help anybody with this concept of infinity, this mathematical concept? I would be glad. If you have a question, I guarantee a bunch of other people on Zoom also have the same question. So I'll just pause for a second and see if anybody wants to ask. So let's go on to the third argument, and now we're going to switch over to arguments from science. So the first scientific argument has to do with the expansion of the universe. So as you trace the expansion of the universe back in time, everything in space gets closer and closer together. So according to the Friedmann-Lemaitre model, which is the standard Big Bang model, that's what happens to space as you go back in time. So this standard Big Bang model currently is the dominant cosmological model of the universe. So this model is what virtually all cosmologists, physicists, astrophysicists think is the true model of the universe. And in that model, the universe is expanding. It's getting bigger and bigger and bigger as time goes by. So if you start going back in time, eventually the distance between any 2 points in space becomes zero, so you can't get any closer to that. So if we go back far enough in time, we reach a point which is the boundary of space and time. And space and time can't be extended any further back than that in our universe. It's literally the beginning of space and time. So a picture is worth a lot of slides. So think about today. So you have time on the x-axis and time on the y-axis and space on the x-axis. So think about in time, if we're like here today in time, and if we go backwards in time this way, you see the universe, the diameter of the cone is getting smaller and smaller and smaller. So that's space. So literally the space in the universe is shrinking if you go backwards. And if you go back far enough, you end up at a point here, which is called the singularity, which is where space has shrunk down to nothing. Like space disappears. And time also begins at that point. So time begins here. I can write. That is chicken scratch. So time begins there and space begins there. And it's called the initial cosmological singularity. So this is what our best and brightest scientists tell us happened about 14 billion years ago, is when the universe literally came into existence, when time and space began. And in this presentation, I'm not going to go through all of the competing models that, if you read the chapter, he talks about a bunch of different models of the universe that are trying to compete with the standard Big Bang model. And the upshot of all of the competitors is they all keep losing because the empirical data keeps disproving their models over and over and over again. So the standard Big Bang model keeps on going. I mean, Einstein kind of kicked it off in 1920-ish. And for 100 years, this model of the universe keeps gathering more and more and more empirical data. It seems unlikely at this point that science is going to reverse itself on this model, which is basically that the universe is expanding. And if you remember from the chapter and also from the video, he mentioned there are these three cosmologists or physicists, Bohr, Guth, and Vilenkin, who wrote a paper in, I think, 2003, where they proved mathematically that for any universe that is on average expanding, it has to have a finite beginning in time. It cannot be eternal. So those three scientists mathematically showed that for any universe that's expanding, there has to be a beginning. So they kind of have destroyed the idea that we could have an eternal universe. And atheists, for the last 100 years, it's pretty actually amusing to go back and read over the last, especially the last 50 or 60 years, because you have all these atheist physicists who say the funniest things. That, they'll say things like, the thought of a beginning of space and time repulses me, or the thought that the universe began is terrible, and I have to find a way to get around this, because they know what the implications are, right? The implications are, if the universe began to exist, that something had to cause it. They're not stupid. They know that's where the evidence is leading. So they keep coming up with another model, another model, another model. They keep trying and trying and trying to prove that the universe never began and has always existed. And they just keep failing over and over and over again. All right. So the next argument, scientific argument, has to do with the laws of thermodynamics, and in particular, the second law of thermodynamics. And to me, I mean, this argument is really good because it's easy to understand, and it just makes total sense when you think about it. So I love teaching this argument because it's just so good. So according to the second law of thermodynamics, unless energy is being fed into a system, that system will become increasingly disorderly. And disorder is sometimes called entropy. So it means entropy is going up. Or put another way, the heat in the universe is always cooling down. And since heat is energy, then the energy in the universe is always decreasing. At least the usable energy is always decreasing. That's what the second law says. So just an example, if you have a cup of hot coffee and you've heated it up, I prefer about 130 degrees, and my wife likes it about 140 degrees. And you might be thinking, well, how do you guys even know that? Well, we have one of those fancy Ember mugs that you can, with an iPhone app, you can set the exact temperature of your coffee. It's super cool. You should really get one, but they do cost $80. So maybe you don't want to get it. Anyway, when you have a hot cup of coffee, what happens? The coffee cools down, right? All of the hot air from the coffee goes out into the air around it. It's never the opposite. Wouldn't that be awesome? Like if you just set your cold cup of coffee out on the table and it sucked all the heat out of the air and it became 130 degrees, that would be really convenient. But unfortunately, that's not going to happen in our universe because of the second law of thermodynamics. The second law says that when you have a source of heat, that source of heat is going to dissipate and cool down. So that's all the second law is. And of course, I have to work the dog in. So this is an example of temporarily running out of energy. So, the dog is not dead. He's just asleep. So he's not completely run out of energy, but he definitely needs to be refueled to, wake back up and do whatever little dogs do. But this is what happens to everything, right? Everything runs out of energy. Everything's decaying. Everything's cooling down. you're constantly having to feed fuel or energy into a system for it to keep working. That's because of the second law of thermodynamics. Okay, so the end of the world. In the 19th century, scientists realized that the second law implied a grim prediction for the future of the universe. Given enough time, all the energy in the universe will spread itself out evenly throughout the universe, just as the heat in the coffee cup spread itself out evenly throughout the surrounding air. So what this means is that the universe will become a featureless soup in which no life is possible. Once the universe reaches such a state, no significant further change is possible. It is a state of equilibrium in which the temperature and pressure are the same everywhere. Scientists call this the heat death of the universe. So this is an illustration of this. So you have on the x-axis time, and on the y-axis you have usable energy. And so what they're saying is that eventually out here, the whole universe is going to run out of usable energy. And so all the stars are going to burn out. There's going to be, all life is going to die. There's going to be no heat left in the universe. Everything's just going to fizzle and die. And that'll be this thermal equilibrium. And, that's where we're headed someday. I don't remember, I haven't read recently how many billions of years they think that is, but, it makes sense, right? Our sun is eventually going to burn out and become a cold, dead star and not give out any heat anymore. And obviously, when our sun quits giving out heat, then life on Earth will be impossible. And actually, if our sun even gives off a little less heat, life on Earth won't be possible, but that's another story. That's where we're headed eventually. So this unwelcome prediction raised a further puzzle. If given enough time, the universe will inevitably stagnate in a state of heat death, then why, if it has existed forever, is it not now in a state of heat death? If in a finite amount of time the universe will reach equilibrium, then given infinite past time, it should by now already be in a state of equilibrium. But it's not. We're in a state of disequilibrium where energy is still available to be used and the universe has an orderly structure. So if we go back to this picture, we're not here, right? We haven't reached heat death. We're still alive. We still have stars burning. So we're somewhere on this line, I'll just say we're here on this line. Well, if the universe has existed an infinite amount of time, then we would be down here, right? We would already be there because the usable energy in the universe would have been used up an infinite amount of time ago, but it hasn't. We're still here. So therefore, the universe must have begun the energy. Think about back here at the Big Bang, you had all this energy that was input into the system, and it's getting used up ever since that occurred. But it could not have happened an infinite number of years ago, or we already would have reached equilibrium and the whole universe would have died. So the universe had to have begun a finite time ago, or the second law of thermodynamics is false. And, there's no empirical evidence for that. So put another way, if the universe is winding down, then it must have been wound up by something a finite time ago. That's really the only option, is however long ago, 14 billion years ago, someone or something injected a tremendous amount of energy into the universe when it began. And ever since then, that energy has been running down. So it must have been a finite time ago when that occurred. So this leads us to the conclusion, right? On the basis, therefore, of both philosophical and scientific evidence, we have good grounds for believing that the universe began to exist. And since whatever begins to exist has a cause, it follows that the universe has a cause. So we've argued successfully, I think, that the universe has a cause. Now we get to Bob Kober's question from last week, which was basically, well, why is this cause personal? And, how do you arrive at a personal cause? Maybe it was just, another universe that caused our universe, or some other physical thing. Well, what can we say about the cause of the universe? Well, it must therefore be a transcendent cause beyond the universe. So this cause must be itself uncaused, because we've seen that an infinite series of causes is impossible. If you recall, last week we had the chandelier, and I kept drawing chains on the chandelier. They can't go on forever. You eventually have to have a ceiling which holds the chandelier and all the chains up. So we know an infinite series of causes is impossible. So the cause of the universe must be the uncaused first cause. And keep in mind, right? So the simple thing someone could say that doesn't like this conclusion is they could say, well, maybe our universe came from another universe, or maybe our universe came from a multiverse. But do you see how that doesn't help at all? Because from philosophy and the things we learned about infinity, you still need a beginning to that thing which caused our universe. And you can't keep adding one universe after another to cause all these universes, because now you're just doing this infinite regression. You're adding chains on the chandelier, and you're never getting to a ceiling. So saying, well, yeah, our universe started 14 billion years ago, but it's just in a long chain of universes, right? It doesn't solve the problem at all, because of the other arguments we've gone over. And by the way, the scientist Borguth Vilenkin proved that any universe that is expanding has to have a beginning. I mean, they're physicists, and I think all three of them are atheists, which is ironic. And they proved that the universe had to have a beginning if it's expanding. So to me, there's like no escape from these arguments. And I've heard every possible answer. And what happens is, the answers offered by skeptics are always counter to the scientific evidence, counter to the philosophical evidence, and they just boil down to wishful thinking and made up stories. So the cause must transcend space and time, since it created space and time. It must be immaterial and non-physical. It must be unimaginably powerful, since it created all matter and energy. And it must be a personal being. Well, why is that? Why does it have to be a personal being? Why can't it be whatever, another physical object that caused the universe, or another state, another physical state? So why a personal cause? Because if a cause is sufficient to produce its effect, then if the cause is there, the effect must be there too. That's what sufficient means, at least in logic. You have necessary causes and sufficient causes. A sufficient cause means when that cause is present, it must produce its effect. So if you have that cause there, then the effect must be there too. So here's an example. Water freezes when the temperature is below 0 degrees centigrade. The cause of the freezing is the temperatures falling to 0 degrees. If the temperature has always been below 0 degrees, then any water around would be frozen from eternity, because the temperature being 0 degrees is a sufficient cause for water to freeze. So if we had the temperature below 0 degrees for infinity, then the water would be frozen from eternity. It would be impossible for the water to begin to freeze just a finite time ago. Now, the cause of the universe is permanently there since it is timeless, right? We just said that the cause of the universe is timeless. So if it's always there, then why isn't the universe permanently there as well? Why did the universe come into being only 13.7 billion years ago, or however long ago it came into being? Why isn't it as permanent as its cause? And so here's the answer. The answer to the problem must be that the cause is a personal being with freedom of the will. So his creating the universe is a free act that is independent of any prior conditions. I mean, that's what free will means, that it's not determined by prior conditions. If your decisions are determined by prior conditions, then you don't have free will. So his act of creating can be something spontaneous and new. Thus, we're brought not merely to a transcendent cause of the universe, but to its personal creator. That's how we arrive at a personal creator. All right, that's it. So next week is chapter 5. Let me stop sharing so I can see everybody. Okay.
Billy, I have a quick question.
Yes.
So, I followed right up until the personal creator part. Is another way of saying that is that the creator made the choice? Is that another way of saying that? A personal creator,
Yes.
that it made a choice to create then and there, and therefore it must be or the cause of the universe made a choice.
Yes.
Okay, and that's why it's a personal creator.
Exactly. Otherwise, if the cause was always there of the universe, then the universe would always have existed. And I mean, that's a problem, right? So the cause of the universe had to exercise a choice.
Gotcha.
And by exercising that choice, the universe was created. And that's really the only plausible way I've ever heard to explain how it is the universe could come into existence, with the cause always being there.
Because the cause is universe is
Timeless.
Timeless.
Yep. If nobody else has any questions, then I will close us in prayer. All right, let's pray. Father, I thank you for this group of people. I thank you that you've given us a curiosity to learn about you, to learn about all of the evidence you've given us that you exist. And Lord, I thank you that you're teaching us every week that you are there, and there's plenty of evidence for your existence, Lord. You've left it literally all over your creation if we would just look and pay attention. And Father, I thank you for that you're not a God that hides from us. You want us to know that you're there. And Lord, I pray as we learn these arguments, that you would give us wisdom to know when to use these arguments in discussions with our friends and family. and that you would guide those conversations, and that they would be fruitful in bringing people to your kingdom. It's in your Son's name I pray. Amen. See you next week, chapter 5.